Alright folks, today we are going to talk about using the graphs of sine, cosine, tangent that we learned last class and seeing what they look like under scale changes. So to begin, I want you to grab out just a piece of scratch paper and we're going to sketch what we remember from last time on what each of our parent trig functions look like. Okay, so pause the video if you need to grab out some scratch paper. So to begin with, and you'll keep this handy all throughout, what I want you to do is give me just a basic idea of what sine, cosine, and tangent looks like. Okay, but what I want you to do, as well as just doing the basic shape, is I also want you to label the x-axis with the important values 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so pause the video and try that for me, please. Okay, so sine starts at 0, okay, because at 0 degrees the y value is 0, and then does that wave shape past that. And so the important values, every pi over 2, something's happening, whether it's a max, a 0, or a minimum. So here's your pi over 2, where it's at the maximum, pi, 3 pi over 2, and 2 pi. And that just maps over that way as well. Cosine starts at 1, because at 0 degrees the x value is 1. And that goes down on each side. Again, every pi over 2, something important happens, so 0 is first on this one, and then it goes to the minimum at pi, 3 pi over 2, and we finish up at the maximum at 2 pi. Tangent, the way I want you to graph this one is still starting with 0, 0, but also we have to think about where tangent is undefined, and that is at the asymptotes. So it basically goes 0, asymptote, 0, asymptote, and so on. Okay, so I'll go this way as well for just a couple. From there, it makes just a snake shape, and you can use your asymptotes to guide you. So these asymptotes appear at pi over 2, then we're back at a 0 for pi, then at 3 pi over 2, and continuing that pattern. Now, we wanted to review this because what we're going to do is take a scale change, and that's going to stretch our graph up and down vertically and change where some of these things look like for their maximums, or kind of how the shape changes, and then also horizontally, which will affect where the important points on our graph actually land. Okay, so something I want to point out before we get started that's important for all of these is a reminder of the period, because horizontal in general is going to be more challenging for us to think about, and so we're really going to focus on the amount of time it takes to complete a cycle. So notice at sine I start at 0 and end at 0. I have to go up and back and through to get there. At cosine I start at the maximum, end at a maximum to get to the period. Okay, and then of course the period on tangent can be seen from one asymptote to another, just the single pi. That is going to be important for how we sketch these with our scale changes, remembering that period. Okay, so I'm going to throw it back to chapter 3 for a minute. You were given this formula on a note card, but basically all we did to figure out what the a and the b values were basically just reciprocate what we saw in the equation. Okay, if we saw a divided by b, we knew that really meant in our scale change we would times by b. So this one would look like ax and this one by, because we would change division to multiplication. We're going to use this same formula to talk about our trig functions, sine, cosine, and tangent. Okay, and so I've written just this with sine as an example, and there's 2 tweaks that I made, and I want you to write this down at the top of your paper and we'll use it. But for the first thing is, since equations go y equals, I just solved for it by moving that b over. I replace the f of x with sine. That's the parent function we're looking at. It can be interchange with cosine or tangent. And then x divided by a is the same thing as multiplying by the reciprocal. And because we've practiced just changing it to the reciprocal, that's how we'll look at it in terms of what we're doing today. Now, how these relate to our sine and cosine is the b value gives us a vertical stretch or compression. Okay, so with b, it's just like purple note card way back when, is going to be up and down on the graph. Okay, whereas the a value, since it's inside with x, is going to be horizontal. So our b goes with what's called the amplitude, and this actually only goes with sine and cosine. There's no such thing as an amplitude for tangent, because the amplitude is actually just the distance. If we think about our graph of sine and cosine and make this wave shape, it's the distance from the center of our graph to the maximum, or the center of the graph to the minimum. Okay, basically just that height of each of those little arches. Okay, then our a value, since we decided it was horizontal, is going to affect that period, and that's kind of what I was talking about. Now, we can calculate our period with the shift either by taking 2 pi times a when it's sine and cosine, because that's the original period, or pi times a if we're dealing with tangent, since that's the original period. Okay, so take a minute to just jot those things down, and then the more we use them, you'll get the hang of it. We will have a note card for some of this information, but we're going to fill it all out when we have the translations as well next class. Okay. So here's what we're going to look at. On our graph, we've got a 4 in front, and remember that's going to be our b value, and all it does is vertically stretch our graph by a factor of 4. Okay, so we can answer these questions just using that number there. The period is only affected when we see something inside with the x, so it's going to stay the same it normally is. Since we're dealing with sine, that'll be 2 pi. The amplitude is what's going to change. Normally our amplitude for sine is based on the height we talked about, is just this distance. We know that the maximum height for both sine and cosine is 1. Well, if we stretch it by a factor of 4, what that's going to do is increase the height of our curves for each of these, and so now that distance is 4 instead of 1, and that number is directly the amplitude. And that's why you can see on that last screen, I'll go back real quick, that absolute value is just the amplitude. Why we take the absolute value for both of these, both amplitude and period are distance measures, so if there's ever a negative, it deals with the reflection, it doesn't deal with the distance, so we'll just leave that off. Now, last thing, I haven't talked to you about it, but I'll just draw an arrow here. Frequency is just 1 over the period, or the reciprocal of the period. So ours was 2 pi, it'll look like 1 over 2 pi. All this says is you're doing 1 cycle in 2 pi radians. Okay, so it takes 2 pi to get 1 lap done. Alright, and now what we can do is describe, kind of like purple note card, in a sentence what happened. We said that this was up and down on the graph vertical, so we'll say the graph of, and our parent function was sine this time, y equals sine x, has been, and I don't want you to abbreviate in this, so vertically stretched. We'll spell it all out. And remember, we do want to say by a factor of, so by a factor of 4. Okay. Now we're going to go ahead and graph it, and this is why I had you sketch what sine, cosine, and tangent look like, because we're going to use those things to guide us. Since we decided that our vertically we are getting basically higher and lower on the bottom end, really the only thing that's going to be changed in your original graphs are the maximums and the minimums. So we know sine starts at 0. If you multiply 0 by anything, it's still 0, so that stays the same. But all of the values in between are going to get stretched, And to figure out how to sketch this, honestly, we only have to use the important parts. Okay, that's why we practiced so much last time, deciding that something important happened every pi over 2. So we know we have to go up from there, but instead of going up to 1 like we normally do, we're going to go up to our new maximum of 4. Then sine comes down, and we're back at 0, because 0 stays the same under a vertical stretch. Okay, then we're going down. Instead of to -1, we're going to -4, and then back up to 2 pi, just following the pattern of the original graph, just stretched out. Same thing over here. I was supposed to go down. Normally that's -1. We're going to -4. From there, you have nowhere to go but up, so you go back up to the 0. Then we're going up to the maximum, which is now 4, and back. Now, one detail we're paying attention to here is it says less than or equal from -2 pi to 2 pi, which means they don't want you to put arrows on the end of this. They just want you to end it at this -2 pi stopping point. And then we'll just sketch our curve through here. Try to get it as round as possible, but sometimes they get a little bit messy, so just do your best. And that's it for this one. In general, our vertical stretches are going to be easier to graph, which is not happening on the next one. Okay, so because this says 2x, it deals with the a value. Now if you look on the top of your page, I had you write 1 over ax. That means that a here is really 1/2. Okay, so this is going to affect the period, and all we have to do to find the period is take the original and multiply it by that a we just came up with. So cosine the period is normally 2 pi. We're just going to multiply it by 1 over 2, and we get to pi. Now I'm actually going to skip to the frequency because I want you to understand what this is saying. Okay, so the frequency is 1 over just that value you get, but it's saying it's doing 1 cycle now in pi instead of taking 2 pi. This says 2x. It literally means that cosine is cycling 2 times as fast. So if you see 2 in front of x or 2 in front of theta, it's a direct relationship with the frequency, whereas it was the reciprocal for the period. We had to flip that thing. Okay? So if we go twice as fast, that does take the period and cut it in half. So you can see it from that as well. Amplitude is just a number out in front if we have one. We don't. So for sine and cosine, the amplitude automatically is 1. Okay, that's the height to the maximum from the center. From here, we can go ahead and write a sentence. Again, we're going to start with the graph of. And parent function is y equals cosine x. Always say has been. And then we're going to talk about what happened with our a and b values. So left and right on a graph because we're inside with x, so has been horizontally. Okay, and if you think about purple note card, you'll have to look at this number and see where it fits, the original 2x, but you can also think about what happened to the graph. Okay, so I took my graph and it used to take 2 pi and now it takes only pi, so it kind of got scrunched, so that is horizontally compressed. By a factor. And I will actually accept either 2 or 1/2 here. Okay, purple note card says just use the number 2. So that's what I'll write down. But remember, anything on the inside with x, whether it's the h value or the b value, it's kind of the opposite of what you think. So really, if we're making something smaller, it's a factor of 1/2. But we're saying compressed, so I'm okay with you leaving it as 2. Okay, now here's where we have to work hard to graph it. Okay, so I'm going to draw a little sketch, but you have it on your notebook paper already of what cosine looks like. And I told you that what was going to be important for horizontal is the period. We're actually going to start with the important markings on the period. So for cosine, that's the maximums. For sine, it went from 0 to 0. So from maximum to maximum is the period. And generally that is 2 pi. But we're supposed to have it as pi. So what we're going to do is start with our original point. It's still at 1 because we didn't have an amplitude change. But instead of putting the next ones by going pi over 2 at a time, we're going to skip way to the end, and our end should be at pi. So go over pi and mark that same point. Then we're just going to use what we see in the graph to mark the rest. You'll notice halfway in between the maximums, you'll find the minimum. So we're going to do that next. Halfway between would be pi over 2 for us. We want our minimum value, which is at -1 because, again, we didn't have an amplitude change. Okay, then halfway again gets our zeros. So at pi over 4 here and here, we'll hit those values. And then we're just going to repeat this over and over again. Okay, so from here, again, we're going over pi. Then we do the halfway mark. Well, halfway for each of the zeros. What I want you to do is pause the video and see if you can do that same thing on the left side of the graph for me. Should have been maximums at -pi, -2 pi, minimums right in the middle of those, and then halfway we hit those x-intercepts or zeros. Again, because of the endpoints, we're not putting arrows on this. Try to curve when you hit the max and the mins, so it looks round, rather than just straight lines connecting these. And you've completed your graph. The last two are going to put the two things together, see if we can handle them both at the same time. So this one, we've got a vertical something and a horizontal something. Our job is to figure out how they affect the period, the amplitude, and the frequency. Okay, so remember, what you see is what you get for B, but with A, you just reciprocate. So the amplitude is that B value, 1/4. We don't have a negative to worry about the absolute value. And the period, you just take something times A. And the something is based on the parent function. Always check this, because sometimes it'll be 2 pi and sometimes it's going to be pi. For sine and cosine, we use 2 pi. So 2 pi divided by 2, or times 1/2, is just regular pi. Remember, if you see 2x, that means 2 times as fast. Frequency is just the reciprocal of what you got in part B. Alright, so the graph of parent function is sine, and we just have to list both of them. Because both of these deal with multiplication, it doesn't matter what order you write them in. In terms of purple note card stuff, we generally don't have two at the same time. With sine, cosine, and tangent, often you will. Okay, so I'm going to say the 1/4 first, so has been vertically, and if my amplitude is now 1/4, it got smaller, so vertically compressed. And then we go to the horizontal. Okay, so let's think here. If you see a 2x here, and if you have purple note card, it'll tell you what that means. Okay, but we used to get done in 2 pi with our sine, and now we're going to get done with our cycle in regular pi. So it's going faster, but it's been smushed, so horizontally compressed again. So we're always using a factor of, and you can say 2 or 1/2 here, it's your choice. Okay, purple note card is going to have you use 2. I'm fine with that. Alright, so what we're going to do is think about this in terms of our graph and kind of help ourselves out with just honestly changing the scale. So this scale was made for the last one so that it was stretched out, but we know that our highest value is going to be 1/4. And that's not going to use much of our graph, so what I'm going to do is just call this 1/4, call this 2/4, 3/4, and 4/4. That way at least we're going up to this height. Now, we're going to think about the original graph. Again, you have this next to you, and when you're doing your homework, it's fine to have it there as long as you can recreate it on your own. Okay, because on a homework quiz, you'll just have to sketch this by yourself. Okay, so sine starts at 0 and goes up. And kind of like what we did last time is we're going to think about the period to graph this. Okay, but if we think about this, it's the distance between the zeros, or the x-intercepts. That distance normally is 2 pi. For us, it's going to be pi. So we can start with those because 0 isn't affected by the vertical stretch. Okay, so let's start at 0, 0, and at pi. Alright, but again, we have to look at the halfway point. The halfway point for this is another 0. Okay, whereas last time we were dealing with max and mins. So we're putting another 0 in the middle. Then our halfway points between those are our max and mins. And here's where the amplitude is going to come into play. This is normally at 1, but because of our vertical compression, it's going to only be at 1/4. So halfway point at 1/4. Then over here, halfway point, instead of at -1, we're at -1/4. Again, let's fix this scale. That way we're a little bit more stretched out. So right there. Okay. What I want you to do is pause the video and see if you can do another cycle just like that to the right and on the left-hand side. Okay. These ones are trickier in general, but here's my starting point, here's my ending point. In the middle is another 0, and then I'm going up first and then down next. On this side, I know I have to go down. Okay, when I'm going down here, I'm using the guidance of my zeros. So again, 0 at -pi, 0 halfway in between, but I know in between that I have to go down. Okay, then on this side I must go up, and then I'm going to continue that pattern. If you figure out how often everything's happening, like in this case, it's happening every pi/4 instead of every pi/2, you can use that pattern to kind of walk through what this shape should look like. Okay, so what I mean is here would be pi/4, I go down, pi/4 more, I have to go back up, pi/4 going up still, and then pi/4 going down. And you can map it that way as well. Go ahead and connect all those. Remember, no arrows on the end. Stop at that 2 pi because of the instructions. And then I didn't get as round through some of these as I could have. So just try to do your best on that. As long as they don't look like straight lines, you're okay. Alright, the last one I want you to try out and see if you can think about, because it's another putting two different types together. So if you can handle this one on your own, then you won't have any trouble graphing for your homework. Okay, pause the video and try this one for me. Alright, so go ahead and check your work over here, your sentence, and I didn't graph this one intentionally yet so we could talk about it together. Because our period is so long, this one's a little bit different on how we want to graph it. Same process, but we can't think about our period from maximum to maximum here because we won't actually be able to see this if it's 6 pi. Our graph only goes from -3 pi to 3 pi, so we have a distance of a whole period, but half of it's positive and half of it's negative. Okay, so we have to think about this just a little bit more carefully, but process is very similar. Okay, what I would recommend doing, honestly, not only just look at your scratch paper, but sketch one kind of like I did below this, or for anything that's a little bit tricky, so you can physically write on it. I know that my maximum should start at 0, and because of the amplitude, it's going to be at 6 instead, so I know that much. But I have no way of putting the next point over. Instead, what I'm just going to do is still think about halfway points. So if I think about the halfway point, I can't visually mark it in half, but I can take the number and split it in half. So this in the middle should be 3 pi, and we do have that on our picture. And at 3 pi, we should hit our minimum. So at 3 pi, we can put our -6 because our stretch here. Then, halfway in between those, so halfway from 0 to 3 pi, okay, you can visually split it, or it's 1.5 with the algebra, okay, we should hit the 0. Then, with symmetry, the same thing's going to happen on this side. So, again, at the -3 pi, we're going to hit our minimum, and then the halfway -3/2, we're going to be at 0. So, round because this is the minimum, then curving to get to the maximum, back down, curving to hit that minimum, and that's it. It's a full period because we went minimum to minimum. It just looks a little weird. That's about the toughest you're going to see. Usually you have enough space to be able to graph a couple cycles, and it gives you more room to work with in terms of your graph and what you see. The last thing we're going to talk about is how these can be applied, and I want to just kind of backtrack a little bit on each of these graphs with some notes that will help you for your homework. So we talked about vertically stretched. With vertical stretches or with the amplitude, it also tells us loudness. So if we see a vertical stretch, that means it got louder by a factor of 6. And then the period is going to talk to us about pitch. So if our period has gotten longer, it's stretched out, the pitch is lower. If the period has gotten shorter, or the frequency is faster, that makes a higher pitch. And specifically, I want to focus on the ones that had the 2 times. So on both 3a and 2a, you saw a 2x in between. I want you to write yourself a note of this because it will be asked on the homework, a question specifically about this. When you see a horizontal compression by a factor of 2, not only is your pitch higher because it's a shorter period, it's actually an octave higher. So let's make a note of that, 1 octave higher. So if you ever have to go an octave higher, you just split your period in half, or there's a 2 in front of your x in the equation. Similarly, if you want to go an octave lower, you'll see 1/2 in the equation, and your period would just be doubled, so it would go to 4 pi. Alright, now we can go back to what we were talking about, and it deals with some equations here. It gives us a graph of a regular trig function and a scaled one. So it told us cosine, but I shouldn't have to tell you that. In fact, I may not. You decide by looking at the original point. The original point can be at 0, 0 or 0, 1. In this case, it's 0, 1. That's what makes it a cosine. It starts at the maximum. So we're going to look at 2 things on this graph. We're going to check out the period of the new one and the amplitude. So instead of at 1, we are at 3. So that's our amplitude, or our height. And the period, you can measure from maximum to maximum, minimum to minimum, or any point and its corresponding point. So if we have enough room, I like to go max to max or min to min. We do have enough of a graph given because you can see 2 maximums. We're just figuring out how long it takes to get there. And looking along the x-axis, it is 6 pi. Now, 6 pi comes from taking 2 pi times a. So if it comes from that, we can set 2 pi a equal to 6 pi and just solve. That implies our a has to be 3, just dividing that 2 pi over. And if we see a as 3, let's talk about the equation. So y equals, remember from the front side, we put b first, or the amplitude, and then it was 1 over ax, or just the reciprocal of the a value. So we're going to put the 3 first from the amplitude. We decided it was cosine, so we want to make sure we're using that. And instead of 3, we're going to write the reciprocal. I don't want you to just put 1 over the number, because sometimes this will be a fraction. I want you to just flip your fraction. So this is 3, we'll change it to 1/3, and put an X there. So remember, this number directly relates to the speed, or how fast it cycles. This says it's going 1/3 as fast as normal. So that means slower, and it does cycle slower than the original graph. On number 6, it actually applies it to a sound wave, because one huge application of the sine waves, we talked about it in terms of the loudness and the pitch, is sound. So it says, suppose a tuning fork vibrates with a frequency of 440 cycles per second. If the vibration displaces air molecules by a maximum of 0.2 millimeters, give a possible equation of the sound wave produced. So again, we need A and B, and that comes from the period and the amplitude, and they gave us 2 numbers to work with. So those have to go with one or the other. So if you ever see the word per, that's talking about frequency. Okay, 440 cycles per second, just like I told you for the frequency here, this was 1 cycle in 6 pi. So in or per is talking about frequency. With that in mind, we know the period is just the reciprocal of that. So the reciprocal of 440 is 1 over 440. Okay, then our amplitude must deal with this number. When it's talking about displacing air molecules, that's literally the distance away. So this directly is the amplitude. So make yourself a note. If you see this displace air, that is the amplitude. And we're going to use those 2 things to write the equation. Okay, remember the period goes by taking 2 pi times A with sine and cosine functions. Okay, if we're talking about sound waves, it has to be sine or cosine, because those are the ones that make a wave. It says, give me A equation, because technically we could use either sine or cosine, since they have such similar patterns. Okay, but let's go ahead and solve this thing. It's okay for me to divide by 2 pi on this side, but that's going to be ugly over here. So instead of doing that, let's just multiply on both sides by the reciprocal. Okay, so I'm going to rewrite this to the side. I encourage you to do the same so you have room to write work. But we're going to multiply by 1 over 2 pi instead of division. That way we don't have a fraction within a fraction. Okay, now A is by itself, and multiplying straight across we've got 1, and 440 times 2 is 880. Just tack on that pi. And now we can go write an equation. So starting with y equals, hey, remember, the amplitude comes first. So we're taking that 0.2. Then, like I said, you can pick sine or cosine here. It does not matter, because they said any. And last thing, we have to remember what to do with the A. Okay, so 1 over AX, in terms of the equation, we always reciprocate. So if this is A, the reciprocal would be 880 pi. Then we just put the X to the side. And that's it. Okay? If you have any questions while you're doing your homework, please feel free to come see me and get those answered.